Hello students, how are you all? I hope you all are keeping well. I am Priyanka Singh, your science teacher. So today I am here to start with the new science topic. Unit 5, Working of Things, Chapter 13, Electric Current and its Effects. So let's start. Electricity is the most convenient form of energy. We use electricity at home, at office, in factories, etc. The cables or wires you see around carry electricity from the power station to our houses and factories. How does this electricity reach every corner of our house? This is done by laying various electrical circuits. The circuit diagrams are first drawn on paper and then actual electric circuits are laid. In the following section, you will learn to draw such simple circuit diagrams and lay real electric circuits. Table. Are you able to see this table? This table are showing some electrical components with their symbol and brief description are given below. Electrical component, name, figure, symbol, description. So students, please go through this table and try to understand it, okay? The first one is electric cell, and this is the picture of electric cell, and the symbol of electric cell is like this. Description. The longer line represents the positive terminal and the thicker and shorter one of the negative terminal of the cell. Simplest source of electric current. Battery. Its picture and the symbol. A combination of two or more cells. Electric bulb. Picture and the symbol. An electric bulb is represented by a circle with a curved M-shaped inside it. The curved wire represents the filament of the bulb. The filament blows when an electric current passes through electric current. Connecting wire. Picture and a symbol. Connecting wires are represented by a straight line. Generally, connecting wires are made of copper. The wires are used to connect various electrical components in any circuit. Wires connected together. Picture and a symbol. The connection between two wires is represented by a dot at the connecting point. Switch off. Its picture and the symbol. Each switch has 2 points. When the 2 points are not connected, the circuit remains open. This position of switch is commonly called as off position. Switch on. Picture and the symbol. When 2 points in the switch are connected, the circuit gets closed. This position of switch is commonly called as on position. In this position, current flows through the circuit. Electric fuse. Picture and a symbol. Fuse is a thin wire alloy having low melting point. A fuse is always connected in live wire. A fuse of proper rating should be used. Electric battery. The electric cell is a common source of electric current to run a number of devices in our everyday life. Electrical appliances such as the torch, transistor, Walkman, TV, remote, electric clocks and watches, electronic toys, etc. work on electric cells. Many of these appliances use more than one electric cells. When two or more cells are used to draw an electric current, the combination of cells is called a battery. In a battery, electric cells can be connected in series or parallel. A. Battery in which cells are connected in series. Every electric cell has a positive and negative terminal. The terminals are clearly printed on each cell. Connecting cells in series. In this kind of battery, the cells are connected in such a way that the negative terminal of one cell is connected to the positive terminal of the next cell. We can connect as many cells as we need. When we complete connecting cells, in this manner, we will have a positive terminal at one end and a negative terminal at the other end. In given below figure, we have obtained a battery by connecting cells in series. In many devices, the cells are not placed one after the other. For example, in a TV remote control, the two cells are placed side by side in a cell holder to make a battery. In this case, the positive terminal of one cell connected to the negative terminal of the other cell by a metal strip in a cell holder of the TV remote. So, moreover, the order to help the cells place correct in the cell holder is a symbol plus and minus holder. The batteries used in cars, buses, trucks, tractors, inverters, etc. are also made up by connecting cells. A cutout of the car battery showing 6 cells is shown in figure. This type of cells are called storage cell. These cells can be recharged ordinary cells which we use in torches, etc. However, cannot be recharged. Once exhausted, they have to be thrown away. B. Battery in which cells are connected in parallel. When we connect cells in parallel, the negative terminal of all the cells are connected together. Similarly, the positive terminal of all cells are connected together with the help of wires. See figure. We can use a cell holder to hold the cells in parallel. This is the figure which is showing the cells in parallel. Electric circuits and circuit diagrams. The complete path of wires and electrical components through which electric current flow is called an electric circuit, and this is the picture of it. The electric circuit consisting of a dry cell, a switch and a torch bulb is shown alongside. An electric circuit may be closed or open. Closed circuit. The circuit in which electrical current flows from the positive terminal of a battery to the negative terminal through all the components in the circuit is called a closed circuit. Open circuit. The circuit in which electrical contact at any point in the circuit is broken is called an open circuit. No current flows through an open circuit. Circuit diagram. The above electrical circuit can be shown in terms of symbols of the various electrical components in it. This is the diagram of a closed circuit or an open circuit. A diagram which shows the arrangement of various components of the electrical circuit with the help of their symbols is called the circuit diagram. For example, the diagram shown alongside is a circuit diagram of the electric current shown in the above figure. Effect of electric current. Electricity has various types of effect on the object it passes or flow through. For example, it can bring chemical change in the objects. Chemical effect can make different devices to work. Mechanical effect can make an object to behave like a magnet, magnetic effects, and also can make an object hot, heating effect. An extra mile. Electrical devices such as water pumps, mixer grinders, washing machines, fans, coolers, etc. work due to mechanical effects of electricity. Electroplating, that is, layering one metal cover on the other, is carried out on the principle of chemical effect of electric current. Heating effect of electric current. When an electric current is passed through a high resistance wire like nichrome wire, the resistance wire becomes hot and produces heat. This is called the heating effect of current. An extra mile. The change of electrical energy into heat energy is called heating effect of current. The heat produced in a resistor when current is passed through it depends on the following factor: current passed through the resistor, time or duration for which the current is passed, nature of the material. Application of the heating effect of current. The heating effect of electric current has many applications or uses in our everyday life. Some of the important appliances of electricity are given below. Electrical heating appliances. All electrical heating appliances are based on the heating effect of current. For example, electrical heater, electric kettles, electric toasters, electric irons, ovens, geysers, hot plates, hair dryers, etc. work on the heating effect of current. All the electric heating appliances contain coil of high resistance wire called heating element, which is made of nichrome alloy. Electric filament bulb. A bulb contains a thin coiled wire called filament. With the passage of electric current, the filament of the bulb becomes hot and its temperature rises to an extent that it starts glowing. It is therefore very dangerous to touch a glowing bulb or a bulb that has just been switched off. Electric fuse. An electric fuse is a safety device which breaks the electric circuit if there is an excessive flow of current in the circuit, hence preventing damages to the electric appliances and possible electric fire. A fuse works on the heating effect of current. Fuses are available in many different kinds and shapes. These are shown below. A fuse consists of a piece of thin wire, generally an alloy of tin and copper, having low melting point. When excessive current beyond a safe value flows in a household circuit, then the thin fuse wire gets heated too much, melts and breaks the circuit immediately. The current stops flowing in the circuit and thus damage to various electrical appliances is prevented. A fuse is placed on the live wire. A fuse of proper rating should be used. Magnetic effect of current. In 1820, a Danish physicist Hans Christian was performing some experiments with electricity. He observed that when current passed through a wire, the magnetic compass needle kept close by showed a deflection. This came to be known as the magnetic effect of electric current. Electromagnets. An electromagnet consists of an insulated copper wire coiled around a soft iron bar. When current is passed through this coil, the whole system behaves like a magnet. Its magnetism disappears as soon as the current through the coil is switched off. Therefore, an electromagnet is a temporary magnet along with the current. The magnetism can also be switched off or on. These are the electromagnets. Depending upon the type of iron, where an electromagnet can be either a bar electromagnet or a U-shaped electromagnet. Uses of electromagnet. Due to its temporary magnetic behavior, an electromagnet finds extensive use in various industries and scientific devices, such as: first, to separate iron scrap from the junk in industries. Second, doctors use very small but strong electromagnets to remove iron dust from a patient's eye. Third, used in the receivers of telephones and electric motors. Fourth, they are a compulsory part of the pictures tube of television and computer screen. They help in the formation of image on the screen. Fifth, a number of electromagnets are used in a car which help in moving of different parts and generate electricity as well. Sixth, they are used in relay switches. Relay switches allow a small current to switch a large current on or off. Seventh, very strong electromagnets are used to carry the fast-moving maglev, magnetic levitation, trains which run at a speed of more than 400 km per hour. Electric bell. The electric bell is based on the magnetic effect of electric current. Components of an electric bell. The main component part of an electric bell DC are electromagnet. There is a U-shaped electromagnet in which one end of copper wire is connected to the terminal T1 and the other one is connected to the brass stud. It is magnetized when the push button of the bell is pressed. Armature. A soft iron armature fixed to the spring string facing the two poles of the electromagnet. Strip string, a metallic strip slightly bent and fixed to the armature. Contact screw, a contact make break screw. Hammer, made of steel and fixed to the armature. Gong, it is a big metallic hemisphere to which the hammer strikes to produce sound. Switch, a push button type switch. Writing in an electrical bell. In an electrical bell DC, a battery is a source of electricity. One end of the cell of the electromagnet is connected to the positive terminal of the battery through a push button switch. The other end of the coil is connected to the metallic strip string. The negative terminal of the battery is connected to the contact screw. The contact screw is in contact with the strip string at point X. Working of the electric bell. Working of an electric bell involves the following steps. The terminal T1 and T2 are connected to a battery or energy source through a push button switch. When the switch is pushed on, the current flows through. The current flows through the electromagnet, is magnetized and attract the armature. The hammer connected at the end of armature moves to hit the gong and produces a sound. This time the contact between the contact spring and contact screw breaks. As the circuit breaks, the electromagnet gets demagnetized. The coil is no longer a magnet. The armature moves back. The circuit is made again, and as a result, the above steps are repeated. The bell goes on ringing until the push button is released. So it's time for Reader's Digest. Electricity is the most convenient form of energy. The electric cell is a common source of electric current to run a number of devices in our everyday life. The complete path of wires and electrical components through which electrical current flow is called an electric circuit. The circuit in which electrical contact at any point in the circuit is broken is called an open circuit. The circuit in which electric current flows from the positive terminal of a battery to the negative terminal through all the components in a circuit is called a closed circuit. So students, it's time to take your leave. We'll meet in the next class. Bye.